Now here you go. For $31.99, you can get a cartridge overall length gauge for your bolt action. Oh, but if you have a rifle that's not accessible from the rear, then you need a curved one for $36.99, and that doesn't include the attachments that are required for each caliber that run between $5.99 a piece to $12.99 if they have your cartridge. They don't have a couple of mine. They don't have a 300 Savage, and they don't have the 257 Roberts. Well, all you need to have is some Scotch tape. That's it. That, with your set of calipers, which you're going to have anyways at your loading bench. Join me in a second, and I'll show you how to make this an easy job with no cost whatsoever. Now let's establish what we're trying to achieve. That's important because sometimes people get, they go off half-cocked about this stuff and they start getting into difficulties. Cartridge overall length is a specified figure. You can simply go to your hand loading manual and you can follow the figures that they give you in the book, and you're going to be in safe territory and you're going to be shooting very good ammunition. The specified amounts are listed in all the manuals for all bullet weights. And if you look here, and this is a Lyman number 49. It has a typical description, blueprint of the cartridge. And these are not to scale. You can't take a cartridge and fit it on top, superimpose it, and expect it to come out correctly. This is probably bigger than a 30-06 round right here. But in any case, it shows the actual physical dimensions and measurements. The cartridge overall length is the one that's measured from the cartridge head, from the bolt face, all the way to the tip of the bullet, the meat plat of the bullet. And the SAMI industry standard is to not exceed 2.775. That particular standard is set for all commercial cartridges, all recognized cartridges. That is, cartridges that are not home-built wildcat ammunition. That's what, if somebody starts tooling their own chamber, which has been done many hundreds of countless times. If somebody designs their own cartridge and tools their own chamber and fire forms their own brass and everything, they don't have to follow any standards. They basically have to just use their own noggin so they don't kill themselves. But with regard to commercial ammunition, SAMI, the industry association that regulates standardizations of sizes so that everybody's on the same page and they're not producing ammo that all of a sudden won't go into your gun after you just paid for it, or is too loose and blows your gun up. So they establish on a number of criteria which are existing in the industry, and also throughout all the different gun platforms that were ever made for that cartridge. One of the biggest limiting factors to cartridge overall length is magazine capacity length, the length of the internal dimension of the magazine. That has had great influence on quite a number of cartridges through the years. The one that's probably most popular right now, the 223 AR platform, is limited by the military designed magazine. The internal length of that magazine, which was established many years ago back in the early 60s, and it was established on a short bullet, a relatively short bullet compared to some of the ones which shooters are using now. At that time, the military was favoring a 55 grain bullet with a fairly long ogive and a boat tail, and everything was built around the cartridge. So when somebody desires to put a 70 grain or a 75 grain bullet in it, in other words, to shoot extremely long range, to have a great ballistic coefficient, they can't chamber that round correctly with a magazine length that's limiting the overall length. So And that was the case with the 257 Roberts. The 257 Roberts was notorious for being made to overly short book standard. The SAMI standard was overly short to accommodate short magazines, but sometimes manufacturers tried to improve upon something which was a bad design feature of magazines by further exacerbating the problem with a long chamber. So they had a chamber that was longer than the magazine could accept. A lot of guys knew this, and they somehow or another, tried to refabricate the magazine length, or they simply turned it into a single shooter in order to take advantage of the chamber. So this is why sometimes industry standard overall lengths are much shorter than you will find that can suit your rifle. And it's perfectly acceptable. This one here is 2.775, but if you find that your rifle, for instance, in this caliber, can take a much longer cartridge, maybe as long as 3 inches, we don't know. But that's an arbitrary thing that only your rifle can determine, and that's perfectly all right. You don't have to feel as if you're going out off the end of a plank or something because you've achieved a overall length which is in excess of the manufacturer's listed standard. Now there are other standards which are listed in manuals, and those are also designed to assist you and aid you. Right here you'll see, for instance, the 75 grain bullet. Bullets listed for the 257 Roberts are similar to what is listed for the 2506. Bullets weights from 75 grains, sometimes 60 grains, all the way up to 117 or 120 grains. So with shorter bullets, shorter overall lengths may be encountered. In this case here, instead of 2.775, you'll see 2.735 for the 75 grain bullet. And then down here you'll see 2.750. And it's only when you get up to the 100 grain bullet that you start seeing the overall lengths which are consistent with the maximum overall length listed here. One thing that is a standard cardinal rule, if it can be achieved. Now there are certain, like the 300 Savage simply does not have a neck length which satisfies this so-called cardinal rule, but it's generally stated that the length of the bearing surface at the neck should be 1 caliber deep. So if you have a 30 caliber bore, a 308 bore, the bullet should be seated, the bearing surface of the bullet should be seated 308 deep. If you've got a 257 diameter bullet, then the bearing surface, the shank of the bullet, should be seated 257 deep. That's to achieve correct support, so that the bullet doesn't become loose during chambering. And we're talking not about, never include that with the boat tail, any boat tail or anything else. It's the bearing surface of the bullet itself is the part that we're talking about. Boat tails will go in deeper into the case, and that's why sometimes people who are trying to achieve the best velocities for a given bullet weight will find that flat-based bullets will give them a little bit better velocity because it improves the case capacity. Having a boat tail intrudes on case capacity in the boiler room, basically. So you can't put as much powder in the case, and in some events, a boat tail bullet will actually compress powder, and basically it's wasting available space. So don't just automatically go out and buy boat tail bullets because they look pretty, or because everybody says that they use boat tails. There's a reason for them. It's for that long trajectory. So we're getting off point. But once you've established what you have to have as a minimum, you always have to satisfy that. So don't ever. That's the first rule. So don't ever allow your cartridge overall length to bring the bullet out of the case beyond that caliber seating depth. And that's going to occur very frequently with shorter bullets. And it will occur most notably with certain cartridges that were originally designed around long bullets with very long overall lengths. I'll give you a very good one is the 7mm Mauser. The 7x57 Mauser was designed originally with very long 175 grain bullets. They're half as long as a pencil, it looks like. They're very, very long. Well, that chambering was necessitated for that particular long bullet. So when you start seating bullets of standard weight, such as 139 or 140 grain bullets, very frequently the bullet jump is going to be tremendous in order to reach the rifling, and that's perfectly all right. A lot of guys get perfectly good accuracy. That's notably a hunting cartridge. It started out its life as a military cartridge, but it is now regarded as one of the finest hunting cartridges of the world. So there is always checks and balances on this. So what we're trying to do is establish the distance between where the rifling contacts the bullet just before the shank. In other words, the long parallel portion of the bullet is the shank of the bullet. You can see that very easily if you simply place a bullet parallel in the jaws of a set of calipers. You can see where the ogive begins to separate from the jaws of the caliper, and that's what we're looking for. The point where the shank of the bullet begins to thicken enough so that it engages the rifling. Rifling begins at the chamber as a tapered ramp. It's not an abrupt shoulder. It's a tapered ramp, so it doesn't cut into the rifling. It displaces the bullet. Your bullet diameter is the same as your groove diameter. Okay, so there's no gas leakage around the bullet. That's why there's some of the things that are written online, on some of these blogs just don't make sense, because people don't understand that a bore diameter is the diameter from the top of the lands. In other words, the humped up top of the land between those surfaces is the original bore. When they drilled the barrel out, when they hammer forge a barrel, it's all done at once. But in the traditional sense, the bore is what's drilled out originally, and then the rifling is formed by cutting grooves or swaging grooves inside the bore, which further increases the diameter. It's that increased diameter which is the groove diameter, and that's the diameter of your bullet. So your bullet, if your bullet is a 30 caliber bullet, it's 308 because the original bore diameter was .300, but the groove diameter is .308. All right, so it's 4/1000 of an inch on each side of the rifle. They may not be directly opposing. Very frequently, they're not. Very frequently, it's an asymmetrical, dimensioning. So, but at some point, the diameter of the bullet has to satisfy the depths of the grooves. In the case of Sierra bullets, they satisfy it with an additional 0.5 which is very thin. I explained to you in a recent video that 4/1000 of an inch is the thickness of a piece of 20-pound paper that's in your printer. So when you go to Staples and you buy 20-pound printer paper, that's 4/1000 of an inch thick. So we're talking about a very, very, very small amount. You can see that when you start seeing things online where people are fussing about whether or not it should be 2/1000 of an inch back or 3/1000 of an inch back from the rifling, blow it off. They haven't got a clue what they're talking about. What they're ending up with is a cartridge that, if they're that close, anytime you're closer than 8 or 10/1000 of an inch, you're going to have occasionally one round which will contact the rifling and one round which will not contact the rifling. Then you're going to have erratic spikes in pressure, and you're going to have erratic accuracy. You're going to have rounds that fly outside the group for some unknown reason, and the reason is very frequently because that particular bullet happened to be engaging the rifling before the cartridge even went off, sometimes very firmly. And that you say, well, why does that occur? Well, very simply because sometimes you can have a burr on the back of the cartridge base, on the head of the cartridge, that's barely noticeable. Maybe just simply a raised up burr from your extractor from the last time you fired the case or something like that, especially with autos with forceful cycling. It can be something as simple as that. It can be a situation where because of that maybe it's canting the cartridge to one side. So all sorts of things can happen where you don't want to be that close to the rifling. The standard distance from the rifling to achieve the best available accuracy is generally stated to be between 30 thousandths of an inch back to 15 thousandths of an inch back. Now that's expressed in 3 decimals, 0.030 or 0.015, or in anything in between. All right, you don't have to go any closer than that. The quest for super top accuracy sometimes leads bench press shooters to engage the rifling, sometimes even firmly with their bolt handle and everything. But remember, they're talking about target grade accuracy. They couldn't care less whether their ammunition is shooting at standard velocities. In most cases, these guys are shooting underpowered ammunition. All they're interested in is only the group size. It's the only thing they're interested in. So even though they're shooting with 22 or 6mm PPCs that have available velocity levels up way into the 3000s, very frequently they're shooting at velocity levels that are way below that just to achieve the greatest accuracy. So pressure spikes don't even concern them because they don't really they're not working within those realms of dangerous pressure anyway. They're able to seat that bolt down firmly, punch out the best accuracy, and the reason they're seating that bullet firmly is to absolutely ensure that they're actually head spacing on the rifling. That's what they're doing. That's not what you ought to do. Head space is determined by the cartridge datum line or the rim. So don't confuse two issues. You don't want to be head spacing on your you don't want to be contacting and making headspace on your bullet. That's not what headspace is about. So depart from the notion. If you're a bench press shooter, you do what you want to do. You can take this information and regard it for what it is. But if you're shooting standard velocity ammunition at standard velocities, and especially Magnum ammunition at standard velocities at those specified levels, you're working with top pressures anyways. You're working with pressures 50, 55,000, 57,000, 60, 62,000 pounds per square inch. Those pressures can suddenly become extreme, and there's no need for that. What frequently happens is that people will work within those pressure levels. They'll work within those already pre-spiked levels, and suddenly a bolt sticks because the chamber has gotten a little warm or something like that. So they back off the pressure without changing. They back off the pressure by dropping the powder charge down, but without changing the bullet engagement. They've still got a firm bullet engagement with the rifling, so they back down the pressures. Now they're not getting standard velocities. So they've got a 270 that instead of delivering 3,100 feet per second is working around 2790 or something like that, because they're working at cross purposes. In the one case, they were jamming pressures up to the ceiling, and jammed pressures that spiked pressures do not necessarily yield spiked velocities. They don't work hand in glove like that. They work quite apart from one another. So even though a pressure may spike tremendously high, the velocity may not follow it on the same bell curve. So pressure increases should always be increased along the standard bell curve, which is where they operate. If you can imagine that a bullet traveling forward to engage the rifling is given a little bit of a head start. It's like when you're trying to rock a truck out of a mud hole. You know, you get it going. You know that you can't just stand there and spin your tires because it's not going to work. So you gain momentum and you finally get it to the point where you can just simply drive out, and without any force, without any spinning. And that's what you're doing with keeping your rifling you know, keeping your bullet back from the rifling a little bit, is allowing that bullet to simply get a nice start, a nice smooth start without a spike in pressure, a jolting spike. See, that spike in pressure, most of that spike occurs at the early onset of when the bullet strikes the rifling. So that throws the pressure way up to a dangerous level, but it's not the pressure, it's not the long curve of burning powder that's required to get the bullet out of the barrel. So there's two separate curves going. One's a velocity curve and one's a pressure curve. So what you want to have is that you want to have that nice smooth launch of the bullet from behind the rifling. 30 thousandths is a very small amount. You know, just take those pieces of paper. You know, 4 thousandths of paper, 4 thousandths of an inch of paper, remember, is all we're talking about. And we're talking about an angle here. You know, this is you've got an angled. Let me see if I can find my wedge here. The rifling begins as an inclined plane. So you're really not back you're not back 3/100ths of an inch. That's what 30 thousandths is, 3/100ths of an inch. You're not back 3/100ths of an inch from the beginning of the rifling. The bullet itself is behind the rifling. It's very, very close. So at an angle, it's in the rifling. It's actually corresponding with the rifling. All it needs to do is move toward it, and it's contacting it. So you're not jamming it sideways. All around the circumference, the two are very, very close to one another. As soon as that bullet begins to move forward, it's landing. It's like a plane landing on the runway. It's already there. So let's get into it and see if we can show you how to do this. Now, the first thing to remember is to always use the same bullet for the cartridge that you're going to be reloading. Any measurement that you take using this process, or any bullet engaging measurement that you use, always has to correspond with the same exact bullet brand and style. So it has to be the same manufacturer's product. You can't, even within the same manufacturer, you can't assume that you can go from a 125 grain Sierra 30 caliber bullet to a 150 grain Sierra 30 caliber bullet and have the same bullet point ogive. They may be the same, but they may not be. So don't take those things for granted. Whatever you arrive at is for that particular bullet alone. In this case, we're going to be using a Match King bullet. It's a 100 grain Sierra Match King bullet. It's got a long boat tail, and it's got a long slender ogive. The actual bearing surface is only probably about the middle third of the maybe about 55 or 60% of the length of the bullet. So that's maybe half of the actual bullet length. But remember, I don't want to arrive at anything that would prevent my having a full 25 caliber bearing surface within the cartridge case, or at least very close to it. Now the distance that we're trying to determine, as I've told you, is between the bolt face, the front of the bolt face, which is the same as the rear of the cartridge case, to the engagement point on the ogive. Okay, and we won't measure from the engagement point on the ogive like some of these foolish gauges use. We don't have to. We're simply using the bullet point as a reference point, as a measuring tool to establish what it is for that particular brand of bullet. So it doesn't make any difference where the engagement point is. Any gauges that rely on engagement points on an ogive are presuming that they're all the same. You still have to go through the same process with each brand and type of bullet. So it gains you nothing. Having gauges is just simply a way of making money off you that you don't need to spend. Spend it on your bullets and powder. So we're going to we're going to use our cleaning rod to put down in the bore and measure to the length of the bolt face. That's right here. That's where the bolt face is. And we're going to then take a measurement from the muzzle to the point of the bullet, right here, to the very point. So taking those two measurements, we subtract the shorter from the larger and arrive at the absolute overall length of the cartridge. We don't care where the engagement point is. We know that the bullet has already been engaged in the rifling, and we take the measurement from that point. And from that starting point, knowing what the overall length is from a fully seated bullet, a bullet which is contacting the rifling, we then subtract and shorten the cartridge by 30,000ths of an inch and work our loads up from there. So let's begin with that. Now we begin by removing the bolt from the rifle, and if you're using a lever action such as a Model 99 Savage or a single shot rifle or whatever, you just simply move the bolt out of the way. You open the bolt, and in all cases make sure you never allow the firing pin to drop. You want to make all measurements once the bolt is back. You want to make all measurements from a bolt which is a clean face with no protruding firing pin, because that will change your overall length considerably by as much as 30,000ths of an inch. So we'll start by removing the bolt, taking your bullet point first in the regular firing position, and simply drop it down into the chamber. It sounded like it went down cleanly, and I'll simply point it towards a bright light and ascertain that I can see the base of the bullet looking right at me, which it is. Now I take a cleaning rod. Pistol cleaning rod would be good, or you can use just a sectioned rod or whatever you want. A dowel is fine, anything that will reach down there to the full length of the bullet, and just gently push it into place with a little bit of pressure, but you don't have to use extreme force. You don't want to bang it into place. That's the last thing you want to do. You want to have a measurement from a fully seated but not engraved bullet. You don't want to distort the rifling. You just want to press it into place without tapping it, banging it, or anything else. Now we'll move that over to the vise. Now I have made myself a flat probe. This probe right here, the flat surface probe, allows me to take a measurement off of a pointed bullet tip without it sliding to one side or the other. It is possible if it was a close-fitting rod, which this one's not. This is a rod for a 22 up to 25 caliber 6.5 millimeter bore. So if I tried to use the male tip inside, it could quite easily miss the point of the bullet as it's traveling down and give me a misreading. So therefore I just simply purchased an additional cleaning jag. These are inexpensive, and this is where, if you have a slotted cleaning tip or something like that, you can file one flat and use that. But just, you have to be sure that the measurement that you're taking is from the flat point, and be sure that you file or grind this absolutely flat and square. If you have access to a some sort of a surfacing system where that's square, all the better, because we're talking, remember, only about small thousandths of an inch. So now just insert it carefully into the bore, being conscious of the crown. We don't want to distress the crown, and simply move that all the way back to where I'm hitting. Can you hear that? I'm hitting the bullet. I know that I'm all the way to the rear. So I've done this. I've simply used a Sharpie, and I've made a mark. The problem is with this rod here, I can make that mark. I just push my bullet free. I can make that mark, but the mark is up to 0.08 of an inch thick, and then I have to be sure to take my measurements from one side of the mark or the other, which is a little complicated and difficult to see. The other problem is that it marks up my rod, and then I have to clean it all up later on. and if I'm using a black Dewey rod, the system wouldn't work unless I got a white marker. So it's a lot easier to use, and not only that, the angle that I place my pen has much to do with the accuracy of it. It's very difficult to get a pointed pen at the same place on the rod each and every time. So what I'll do instead, and this is the way I found is far more consistent. I just take a piece of Scotch tape. The Scotch tape allows me to position that tape parallel against, perpendicular to the bore. In other words, touching the rifle crown on both sides, touching the evenly, and I can easily see my perpendicular. Let me get that bullet seated again. Okay, while I was gone for a moment, I used my flashlight to determine that the bullet was in fact properly seated into the rifling the way it should be. Now sometimes this is if you're using very small bullets like 22 caliber bullets that want to just fall out of the rifling easily, get another person to help you out, or if you're by yourself, you can tape that rod in place to hold it in place. But it's a lot easier if you have somebody else to assist you. So all I want to do is take a piece of tape which is long enough that I can hold. It gives me a good true indicator. I can see when I'm parallel and perpendicular, and I simply apply it to the rifling without to the cleaning rod without bending the tape. You don't want to curl the edge of that tape. That would be contrary to the whole process. So as accurately as you can, bring it up to the bore where it's touching on both sides, and simply lay it over. And once you've done that, leave it in place. Now we're going to move that bullet out of the way. We're going to simply push the bullet back out, allow it to fall down through the magazine. You can trim off any of this excess tape if it's in your way. Okay, make sure you're like a surgeon. Make sure you recover all your tools from the patient. So I've got my bullet back, so I don't leave that lodged someplace. Now I need to replace my bolt and make sure that I don't pull the trigger. I want to, again, make sure I have my length measured from a clean bolt face and not a bolt face which is influenced by a firing pin. So now I move the rod fully back to the bolt face, and I'll apply another piece of tape as squarely as I can. This one's a lot easier because I can apply pressure with my hand to the cleaning rod so that I know that it's not moving out of the way. That's why it's good to have a partner to help out. These two lead edges are the same as these two lead edges because it's parallel tape. Now don't ever use flexible tape such as electrician's tape or something like that because it's stretchy and it won't remain parallel. And it's also very difficult to get a straight edge because it will very easily curl out of the way, and it will be closer in one particular point than on the other measurement. So if you use Scotch tape is good, even regular paper tape is good. Medical tape is fine. Medical tape is very stiff, as long as it's the one that's not the stretchy stuff. But whatever's easiest for you to see and to use is fine. So now we're going to go pull the rod out, put it on a flat surface where we can lay our calipers and take a measurement. Now with all particular care, and this is vital because thousandths are very, very small, but with all particular care, I've established the point of my calipers against the edge of this tail end of the tape. It's got to be, remember, it's got to be right up against it, making sure that you're touching one end, and then go to the other end and make sure that the knife edge is right exactly at the tape. Once you've established that, then just simply look at your dial and record your measurement. Now the way you read a caliper with a dial is very, very simple. Don't think that you need to get expensive. I consider them less valuable than a dial caliper. A dial caliper is an industry standard. It's always worked. It doesn't require a computer or batteries or anything else. They're extremely precise, and they're mechanical, so they can't go wrong on you. The first number you read is number of inches. So we've got 1 inch, and we've got 2 inches, and the 2 inches we don't see a 3 coming up, but we see 9. This is 9/10 of an inch. So we have 2.9, and then up to the dial we have 30. So 2.930 is our actual measurement for the engaged overall length with the Sierra 100 grain Match King bullet in this particular rifle, and that's it. So from this point here, we start out. It's a pretty simple number. We simply change it from 930 to 900, and that's our starting point. We've shortened the cartridge just by 30 thousandths of an inch, and then as we remember never to get any closer than 15 thousandths of an inch. Okay, so you start from the 0, and then you're only working up between this number here and this number here. That's where 15, from 0 to 15 is our closest that we want to be to this number, which is 30. Don't be surprised when you run across whole numbers like this when you're working with rifles, because this is rifle manufacturers know what they're doing. They're very, very precise about all things. They have to be. They're working with pressures that are right out of this world, and they want to make a good gun for you. So don't ever think that manufacturers don't know what they're doing. Okay, so what's the increment that we're going to be working with? We're going to be working with 5 thousandths of an inch as we work up. You don't need to work any closer than 5 thousandths of an inch. So again, you're going to simply be developing rounds, and we'll show you this during the actual loading process. Just simply write this number down, and make sure you write down this is not a seating depth. This is not a seating measurement. This is a starting measurement, so that you know what your maximum overall length is for your particular cartridge, for your particular bullet style and weight. That's all it is. Record that, and you can keep a notebook for each of the bullets that you measure in this regard. It doesn't take very long to go through the process when you're doing it by yourself. The most important thing is to take care to make sure that you're lining up your measurements on the tape. I've gone so far as to clip something here so that the caliper won't go beyond it, but it's really not necessary. As long as you have that tail end on the tape, you can press it right up against the tail end, and on this end here, take your measurement with a knife, the sharp knife edge, and that's all there is to it. So I hope to see you again soon in the next video. God bless.